Hey, so welcome to the second video of week 5, module 9.05. We just got done talking about the quadratic formula. It's still going to be very useful for what we're going to be doing here, except now we're going to apply it to more like word problem type stuff. So if you're good with the quadratic formula, if you're comfortable with it, then this won't be too much more difficult for you, because the quadratic formula is always going to be the quadratic formula. But we'll see kind of how that applies to these applications, right? So this is kind of introducing our first problem. So I am going to read this because it's relevant to what's going to be on the next page. So we are trying to find, we're trying to frame, I guess, this picture, right? Now the size of our picture is 10 inches by 8 inches, according to this, right? We want the frame of the photograph. We want to frame the photograph so the total area of the frame is 168 square inches. So how can we do that, right? So this does a really good job, I think, of walking you through it. But I'll, like I said, I like to make these videos to sort of help explain what's going on here. Okay. So they have all the information here. They all have all the math here. But let me sort of walk you through exactly what they're talking about with everything. So let's sketch this out, right? We have a picture that is 8 inches by 10 inches. Okay. Now, currently, we could do the math, right? We understand that if we want to find the area of this picture, we just do length times width. Remember, area is simply just length times width. So in this case, 8 times 10, which would be 80. So the area of the picture is 80. But the problem is we want to put a frame around our picture, right? So that the entire area with the frame included, the entire area there is equal to 168 square inches, or inches squared. So how big and how thick does our frame need to be? That's kind of the question, right? So let me, I guess, redraw my graph here, my image. So we have our picture. We want to put a frame around the picture. Now we already know it's 8 by 10, our picture. But what we don't know is how wide our frame is. So we're going to call the width of a frame X, and that's going to be on both sides. So like, let me put it over here, right? So now let's focus on one thing at a time, because it's kind of, I want to make sure you understand where the 2x comes from. So if the frame, or the width of the frame, is X, then on this side, this length, if you will, from one corner to the other, we have the 10 units here, right? We have this X value, that's this length of the frame, but we also have another width of the frame over here, right? Because the frame's on both sides. It's on the left side and the right side. So however long this side is, it's going to be the same on this side, right? So that's essentially an X plus 10 inches plus X inches, right? So X inches plus 10 inches plus another X inches. So a simple way of writing the area, or the length, for this entire side from this corner to this corner would be the 10 inches we already include in the middle from the picture, but we have to add the X twice, once for the left side, once for the right side of the frame, right? So add 2X. So 10 plus 2X is the length of this entire side, right? And now, if we want to consider the width, right? The width is going to be, the width is going to be from this corner to this corner. Now we already know that 8 inches of that is used for this picture. But again, the width of the frame is X on both sides. So X here and X up there. So the entire length is going to be the 8 inches from the picture that we already know, but we're going to add to that length 1X and a second X to get us the boundary of our frame. So that's again going to be plus 2X. So that's why here the length is equal to 10 plus 2X and the width is equal to 8 plus 2X. And so remember, the area formula is area equals length times width. So our area is going to equal length. We know that our length measurement is going to be, let's write this as 2X plus 10, just to kind of simplify things, right? That's my length. And then times the width. The width is 8. Or let's write it again. Let's write it as 2x plus 8. Right? But it's already told us that the area it wants for the entire frame is 168. So we want the area to be 168. So 168 has to equal the 2x plus 10 times the 2x plus 8. So now here's how we start to evolve our quadratic. Okay? So first thing we're going to do is we actually kind of have to work a little bit backwards. We have to FOIL this together in order to start to kind of create the quadratic equation. So to FOIL this, we're going to go first term and first term. So this is the f part of FOIL, 2x times 2x, which makes 2x times 2x makes 4x squared. Then we're going to do outer, so the 2x and the 8. So 2x times 8, that's our outer. 2x times 8. 2 times 8 is 16. So with the x, that would be 16x. And then we do the inner terms. We got 10 and 2x. Those are the two inside terms. 10 times 2 makes 20. And with the x makes it 20x. And then we have the L for last. So remember FOIL, right? First, outer, inner, last. So the last term in this one, the last term in this one, that's 10 and 8, which makes 80. So plus 80. Okay, so we have like terms here, the 2x terms that we can combine together. 16x and 20x. How many x terms is that? That's 36, right? So let's 4x squared plus 36x plus 80. Now don't forget that this is still all equal to 168. So remember from the last video, we talked about a quadratic has to be in the form 0 equals a x squared plus bx plus c, right? So our quadratic that we have here is clearly not written like that just yet. Remember, in order for it to be written in this format, every term has to be on the same side, and it has to be equal to 0. It's very important it's equal to 0. So we got the 168 clearly on the wrong side. So we have to move this one over there. So to move it, we would just, since it's a positive 168, we'll subtract 168. Now, since the 80 is like terms with that, we will combine it with the 80 because they're just two regular numbers. So we're going to combine them together. So on the left, 168 minus 168, as we know, cancels out, makes it 0. And we're going to be left with the 4x squared. We're still going to be left with the 36x. But since these two terms are like terms, we combine those. So 80 minus 168. So let's grab our calculator. 80 minus 168 is negative 88. So minus 88. And now we have our quadratic. Our quadratic is 0 equals, we have 4x squared plus 36x, then minus 88. So we have our a value being 4. We have our b value being 36, and then we have our c value being 88. Now remember, the minus here is black for a reason, because the minus sign means it's a negative 88, and I want to make sure I include that. So now we just use our quadratic formula. So if you missed the last video, please go back, watch it. I'm not going to re-explain everything about it, but our formula, quadratic formula, is x equals negative b, so our b value is going to be 36 here, plus minus the square root of b squared. So we're going to have 30, oops. Oh, it did make it blue. 36 squared. Hold on, so this is getting a little laggy now. 36 squared minus 4 times a, which is 4, times c, which is negative 88. All divided by 2 times a. And again, a is 4. So we have our quadratic formula. Now we just have to evaluate it. So like I said, I color code everything so you can see the a, the b, and the c all plugged in. So let's grab a calculator and let's work it out. So the first thing I always do is the squared part. I always focus inside the radical first. I mean, we're supposed to. solve inside the radical first. So 36 squared, that's probably going to be a pretty big number. 36 squared is the square root here, 1,296. So 1,296 minus, well, let's not do that yet. Remember, I talked about this in the last video. We don't know if that's a minus or a plus yet because we have to evaluate this. Now remember, include this minus sign in your calculation. So in a calculator, you're going to type in the -4 times the 4 times the -88. And in that, we get a positive 1408. So since it's positive, we're going to put plus 1408. All right. Divided by 2 times 4, which is clearly going to be 8. So let's keep evaluating. Let's stay inside the radical. Let's add these numbers together. 1,296 plus 1408 is 2,704. So we have x equals -36 plus minus square root 2,704, all divided by 8. Again, let's take our square root of that number. So if we take the square root of the 2,704, we get 52, which that's nice. When I see numbers like that, it makes me think I'm doing the problem right. It's not a problem if we get decimals. Sometimes you're going to get decimals with this. But the fact that I got a nice, neat number like that really makes me feel confident. So plus minus is still there. Now remember, we're taking the square root. Remember, I just did that in the calculation, take square root. So when you take the square root, means you took it. It's not going to be there. So it's just going to be the 52, not the square root of 52, but just a plain 52, right? Divided by the 8 still. Now this is the part where we branch off and do the plus side once and then the minus sign next. So let's focus on the plus sign. We'll have -36 plus 52 divided by 8. And then the minus sign, we'll do that next. -36 minus 52 divided by 8. So we just have to grab a calculator again and work this out. So let's, -36 plus 52 is 16. So this would be 16 over 8, which when I simplify becomes 2. And on the bottom, let's subtract those. We have -36 minus 52, which would be -88 over 8, which comes out to be -11. All right, now we have two answers, 2 and -11. But think about this. Remember, what this goes back to is the frame of our picture. Remember, we have our picture that was 8 by 10. And then we have the frame. The x value, remember, was the width of the frame. So can that x value be -11 inches? No, it can't. So -11, it works for the quadratic, but it doesn't apply to our example. The only number that makes sense for our answer is a positive number, like 2, claiming that this would be 2 inches wide. That if x is 2, that means the width of the frame is 2 inches wide. So the width of our frame must be 2 inches wide, which is good. So width of frame is 2 inches, not -11, because obviously you can't have -11 inches. It doesn't make sense. 2 inches wide. Now, if we want to double check to make sure our math all adds up perfectly, let's go back to this picture, right? 8, let me zoom in on it as well. 8 by 10. Now, if the frame is 2 inches wide in either direction, 2 inches there, 2 inches there, 2 inches here, right? That means that the length of the picture, let's do it in a different color. The length of the picture is going to be 2 for this part plus 10 for this part plus 2 for this part. The length in total would be 14 inches. And then the width here would be 2 inches for this part, 8 inches for this part, 2 inches for this part. So add all that together, that's going to be 12. So if everything works out the way it should be, the area should be 168. So if we did area formula, length times width, so length times width, then we'd be doing 14 times 12. And if we take our calculator and we do 14 times 12, we get 168, which is the area that it told us to have earlier. So I just wanted to plug the numbers in to make sure that it all worked out nicely, and everything does. So that's very good for me. So my computer's lagging quite a bit here, but that is all. This whole problem worked out. Step 2, all those steps right here explained. Everything calculated. They solve it. They solve it through factoring as well, but we use the quadratic formula. And then you can see them checking the work as well, like we did. So that's what these application problems are going to be. You have to, sometimes drawing a picture really helps. So here we're talking about a projectile in this example. So snowballs, right? We're going to be throwing a snowball. So when does the snowball hit the ground? And then what is the maximum height the snowball reaches? So these are very two common questions, not necessarily about snowballs, but about maximum height and about hitting the ground, because those two things refer to something quite different. I'm going to clear this out, delete. Let's delete this, just because I think it might be making my computer a little slow. I know the calculator is making my computer slow, having my calculator running, but I think we're going to keep it up there for now. Just kind of live with it. Okay. So when you think about a projectile throwing something, right? Maximum height of our projectile, or a snowball, right? Maximum height essentially is the vertex, right? AKA the vertex. So when you're asked for maximum height, you're essentially looking for vertex. Now, when it's asking when does the ball hit the ground, right? The ground is essentially an x-intercept, right? AKA x-intercept, or 0. So you have to read the question to understand what it's asking for. If it's asking for maximum height, it's asking for you to find the vertex. If it's asking when does it hit the ground, it's asking for the x-intercept, or zeros, right? So those require different traits of math. You have to work those problems out differently, because finding the vertex is not the same as finding the zeros. They're different calculations. So if we have our height, let's see, does it give us an equation for our snowball? It should give us an equation for our snowball. Here's the equation of our snowball, right? I'm going to find the time it hits the ground. You can see it's worked out here already. It's got all the stuff here. I'm going to work through those steps. And we're going to find the maximum height as well. And I'll show you how to do those two different things. But let's write down the formula first. So we have height equals negative 16 t squared plus 16 plus 32. So height, h of t, the height of t, height of our snowball at time t is equal to negative 16 t squared plus 16 plus 32. Oh, I forgot the t part in the 16. T, there you go. Looks like a plus sign, but it works. Let me see if I can, yeah, that's so much better. Okay, perfect. All right, so there's our quadratic represents height. Now, if we are looking for, what's the first thing it wants us to find when it hits the ground, right? So hits ground. Okay, now there are two methods to finding this, okay? You can either go through factoring, because factoring will find you the zeros or x-intercepts. By the way, hitting the ground means finding the x-intercept. So you can go through factoring or the quadratic formula. Either of these methods will work to find the x-intercept. Now, I'm going to see if I can factor this. We haven't done factoring in a bit. I think it's helpful to remind it. My go-to when I see this on a test would be to factor it rather than use a quadratic formula. So just to kind of break from what we were doing, let's try something a little different, something we did a week or two ago, and factor it. So when I factor this, the first thing I'm going to find is a GCF. So when you look at negative 16t squared plus 16t plus 32, I notice that all these can be divided by 16. 16, of course, is divisible by itself 16, but 32 is still divisible by 16. Not only that, but since the first term is a negative number, I'm going to divide out a negative with all of this as well. So I'm going to divide every term by negative 16 to take the negative 16 out, which then would leave me with a positive t squared. This will become negative, a negative 1t, or just negative t. And then this will become a negative, which would become a negative 2, so minus 2. Okay, I'm going to put my t's with little curls at the bottom so it stands out from a plus sign. So now what I want to do is factor the rest of this. And I can factor this easily through the what I call the product and sum method, right? So for this trinomial, right, ignore the 16 now. We're focused on the inside of the parentheses. I want to figure out if there are two numbers that multiply to the a times c and two numbers that add to make the b value. Now in this case, our a value would be 1, our b value would be negative 1, and our c value is negative 2. So if I did a times c, I would be doing 1 times negative 2, which is, of course, negative 2. And our b value, which is, of course, negative 1. So what two numbers multiply negative 2 and add the negative 1? There's only one possibility you can possibly think of. Just make sure you get the negative right. That'd be a negative 2 times 1, negative 2 plus 1. That works out perfectly. Now, since, remember, we talked about this in a video once, since the a value is equal to 1 in this trinomial that I'm factoring, that means that my factors are immediately these values, which means my factors will simply be t minus 2 and t plus 1, because I have t as my variable instead of x. Normally be x minus 2, x plus 1, but we have the minus 2 for the minus 2. We have the plus 1 for the positive 1, right? This negative 16 is still technically here, but when you're asked to find the zeros, the x-intercepts, negative 16 is never going to equal 0, so it's kind of something we can ignore. We have to just solve each of these equal to 0. So t minus 2 equal to 0 and t plus 1 equal to 0. So when you solve it, the first one here becomes t equal positive 2, and the one over here would be t equal to negative 1. So since we're talking about the time it hit the ground, right? If you think about this on a graph, the zeros of our polynomial are at negative 1 and at 2. Obviously, at negative 1 seconds, this is back, this is in the past. It doesn't exist. The time the ball hits the ground can't be negative 1 seconds because you don't go backwards in time. So the only time that makes sense for when the ball hits the ground would be 2, because 2 seconds makes sense. Negative 1 second does not. So the ball hit the ground at 2 seconds, right? It's on the x-axis. It's the 0, the x-intercept. 2 seconds makes a lot more sense here. And I think that's what they calculate. Now, they might have used, I guess they didn't. Okay, so they didn't use a quadratic formula. They factored it like I factored it. So hopefully the steps that I wrote down made sense for everything that they have here, right? And they plugged it in. They just checked the work. They plugged in 2 as the t value, and they see that it equals 0. So just to make sure that it worked. So you could solve this through the quadratic formula if you're more comfortable. If you feel like the quadratic formula is more of your go-to, then there's nothing stopping you from that. Of course, you can go straight into the quadratic formula. You'll get the same answer. But I just figured factoring would work out well for that one. So what if you wanted to find the max height, though? So max height is code word, okay, for finding the vertex. So let's see here. Where'd the diagram go? I thought I had a diagram. Did it not have a diagram? I guess it doesn't have a diagram. But max height is your code word for vertex. I mean, I have my diagram, I guess. Remember, so max height is not talking about zeros because it's not talking about when it hits the ground or x-axis or anything. Max height is referring to vertex. So how do we find vertex? Well, remember, vertex is a two-step process. Step 1, find axis of symmetry, and you use the X symmetry formula, which is x equals negative b over 2a. The second thing is to plug in that x value from part 1. So if our quadratic is negative 16 t squared plus 16t plus 32, then to find the vertex, we don't really need much more than, this two-step process. So first thing we want to do is find the X symmetry. So we're going to first find, use that formula of x equals negative b squared over 2a. Now let me color code this, okay, for you. So just, I feel like that's really helpful. So negative 16 t squared plus 16 plus, I forgot the t, right? 16t plus 32. So in our formula, which is x equals negative b over 2 times a, b is going to be 16 in this case, so we'll have x equals negative 16 over 2 times a, which is negative 16. All right, so be careful with the negatives here. So there's the negative that's part of the formula, right? The negative is part of our formula, but then there are negatives that we're plugging in because the a value had a negative, we're plugging in that negative. So be careful with all those negatives. But what we end up with is negative 16 over 2 times negative 16, which is negative 32. And if you calculate that, that ends up being a positive 1/2, so it's 0.5. Okay? So negative 16 divided by negative 32. If you took a calculator and wanted to work that out, negative 16, if you didn't believe me, divided by negative 32 is negative or positive, because two negatives make a positive, positive 1/2 or positive 0.5. So now we plug this x value into the equation. I guess it's a t value in this case, right? So negative 16 times 0.5 squared, because this is going to be replacing the t's, plus 16 times 0.5 plus 32. So you can see I'm plugging in these 0.5s where the t were. So 0.5, 0.5, because there used to be t in that place. So now we just have to, again, type this all into our calculator. So if I try to type, let's try to do all this at once, because if you have a fancy calculator like this, you can. So 0.5 squared plus 16 times 0.5 plus 32. We end up with all of that being 36. So this whole thing equals 36. So that means the height of the ball is, the vertex essentially is 0.5, 36. This is the x value, this is the y value. Remember the x value that we get, y value that we get. So this means that the height of the ball is 36 feet. That's the maximum height, but it also occurs at half a second. Half a second or 0.5 seconds after we throw it, that's when the max height occurs. So half a second after we throw it, it finds the maximum height being 36 feet. I guess that's all explained in this video here. Does it work it out here? It shows you a diagram of it. So if you were to graph it, you could see the graph. There you go, 0.5, 36. You'll notice the y-intercept, they didn't ask for it here, but they calculated that as well. They put it in, so they got the graph of the quadratic overall. This is another example of it. I think they're going to use a quadratic formula in this one, it seems. Sometimes it doesn't seem like it'd be easy to factor. So if this looks too difficult to factor, then just go straight to using the quadratic formula, right? So remember, hit the ground is when you find the roots, the x-intercepts. So hitting the ground is on the ground, meaning it's an x-intercept. Remember, think of it like it was on the graph. Okay, and then max height is your vertex. So let's calculate that for this example. So Max is throwing a snowball, and his function is negative 16t squared plus 18t plus 25. So he has negative, let's go back to red, negative 16t squared plus 18t plus 25. So if we color code that, it's negative 16t squared plus 18t plus 25. So we know the A, B, and the C value. So if we're looking for, remember, where it hits the ground, okay? Hits ground, you should probably make a note of this, okay? Hits ground is referring to x-intercepts, which means, again, either factor or use the quadratic formula, okay? So this doesn't look like a very simple one, the factor, so let's use a quadratic formula. So the quadratic formula, x equals negative b is going to be 18, plus minus the square root of b squared, so b is again 18, so it would be 18 squared, minus 4 times a is negative 16, times c is 25, all divided by, let's extend that there, all divided by 2 times a, 2 times negative 16. So let's just calculate this all out. First thing I want to focus on is, of course, inside the radical, 18 squared. We take our calculator, we hit 18 squared, or 18 times 18, we get 324. So we can have negative 18 plus minus, that turned in, I already forgot. What was it? 324. So 324. The second part, minus 4 times AC. Let's type all of that in the calculator as well. So negative 4 times negative 16 times 25, we get positive 1600. So since it's positive, we're going to put plus 1600. All divided by 2 times negative 16, which becomes negative 32. So we have some big numbers, but let's keep working it out, right? Let's add these numbers together. 324 plus 1600. That's going to be 1924. So square root of 1924 divided by negative 32 still. So let's take the square root now. So remember, we're taking the square root, which means the square root won't be there after I write it out, right? After I work it out. So take the square root. So square root of 1924, we end up with 43.86. X equals negative 18 plus minus 43.86 over negative 32. All right. Just to be safe, I do kind of want to make sure that I'm on the right track here. Because I got a funny decimal, I do want to see if that's what they got. Yeah, they still had the, yep, 43.86. Just making sure. Because you sometimes you get decimals, you think, that doesn't look right, right? So even I feel like that, so it's okay. We want to check our work. But now, since we got the square root gone, now we just want to break this into the plus and the minus section. So we'll have negative 18 plus the 43.86 divided by negative 32, and then we'll have the minus 1. Negative 18 minus 43.86 over negative 32. So again, our calculator, let's add these two numbers up. So negative 18 plus 43.86. So negative 18 plus 43.86. That ends up being 25.86. So 25.86 divided by negative 32. So let's go ahead. Let's divide that by negative 32. Get that answer. We end up with negative 0.8, essentially negative 0.8. And now let's do the other one. So the other one will subtract. So negative 18 minus 43.86. So negative 18 minus 43.86. That's going to be negative 61.86, or negative 61.86. Still divided by negative 32, don't forget. So let's type that in the calculator. Let's divide that by negative 32. We get 1.93, so positive, so 1.93. So there we go. So since we're talking about hits the ground, does it hit the ground after negative 0.8 seconds? Or does it hit the ground after 1.93 seconds? Which one makes the most sense? Obviously, a negative time doesn't make sense, so we're going to stick with this one, 1.93 seconds. And that's what they should end up having. Yep, 1.933. That makes the most sense. So now, how do you find maximum height? So maximum height, let's write down the quadratic again. We had negative 16t squared plus 18t plus 25. So remember, for maximum height, it's not quadratic formula, it's not factoring or anything. It's just going to be the vertex, okay? So remember, vertex is 2 steps. Find axis of symmetry using the formula, and then plug in the x. Oh, step 2, okay, plug in the x. So the axis symmetry formula is negative b over 2a. Now we've already mentioned that b is 18 and a is negative 16. So if we plug this in, this would be negative 18 over 2 times negative 16, which means that we would have negative 18 over negative 32. And if I grab a calculator and work that out, negative 18 divided by 32 is negative 0.5625. So negative 0.5625. So this isn't the final answer. That's just the axis of symmetry. Okay, this is the x value. Step 2 is we have to plug that x value back in to the equation, right? Back into where this t is. So negative 16 times this negative 0.5625. Don't forget to square it. Plus 18 times negative 0. Wait. Hold on. It should be a positive, right? Because a negative times a negative makes a positive. I forgot to type in the negative 32. You can see I wrote it down here, but my calculator forgot to type it in as a negative. So that's my fault. Should have been a positive. So again, you might have noticed that before I did. Sorry about that. 0.5625. And then, of course, what's the c value again? Plus 25? Yeah. So then plus 25. So if we're going to calculate this, let's do it one step at a time this time rather than all at once like I did in the past example. So the first thing we have to do is square stuff. So we're going to have to do 0.05625. We're going to square it. That's going to be 0.003164. Now this number is getting multiplied with negative 16 out here. So I just squared it, but now I have to multiply it with negative 16 as the first term. So I'm going to go back and type in times negative 16, and that's negative 0.05. We'll just leave it at that, right? And then the second part, 18 times this. So 18 times 0.5625. That is 10.125, so plus 10.125. And then plus 25, of course, at the end. So if we add all those numbers together, you'll end up with, so we have negative 0.05 plus 10.125 plus 25. We get 35.075. So 35.075. So that's if you want to do it like piece by piece, like the first part, the second part, and then the third part. But you could, if you have a calculator like mine, you could just type everything in at once. So I'll show you, that's how I did it. The first example, negative 16 times 0.5625 squared plus 18 times 0.5625 plus 25. Now, there might be a small rounding error, but it should be pretty much the same thing as 35. Ooh, it's not. So did I type something in wrong before? I must have typed something in wrong before, because that's a pretty big rounding error to have. Oh, yeah. So my issue the first time was, I see it now. If you look up here, let me highlight it. Yeah. Oh, see, I wrote 0.05625 squared, not 0.5625 squared. So I messed that up. What that number should have been was, see, it's okay to make mistakes. That's why I double check things. 0.5625 squared, right? That should have been the number that I multiply with -16 to make -5. So this number really should have been -5, 0.0625. So I typed that in wrong the first time, so I made that mistake. So it all ends up actually being, if we work it all out again, all should be about 30.0625. 30.0625. If you add everything up correctly. So my fault, it's very easy to make mistakes like that. So that's why it's helpful to go back and check your answer. Let's make sure that they got the same thing that we got. Yep, 30.06. It's exactly what we got. So what that tells you as the vertex goes, the x value, remember, was this. The y value we get was that. So we have 0.5625. This was, remember, the x value we got from the X symmetry. And the y value we just got was 30.06. So this is the max height in feet or inches or whatever it is. But remember that this is the time it occurred. So it occurred at about 0.5625 seconds, right? About half a second. Okay, I don't know if there's too much more to this. Let's see. No, I mean, we talked about this one in the last video as well. It's easy to do this one if you factor it. It doesn't have a C value, so you could just factor out a GCF. So, factoring out a GCF, I would have factored out a negative personally, but, to each their own, I guess, and you can solve it. Same thing down there. You can, again, the second one, to find the max height, you have to still use the vertex formula. So remember, max height is not involving factoring. Max height involves the vertex formula. So they're still using the -b/2a formula for that. So keep in mind, max height and when it hits the ground are two totally separate things. All right, yeah, that's going to be it. I'll let you guys handle it from here. If you have other questions, remember to let us know. Okay, that's it for week 5. I'll see you guys in week 6. Later.